Welcome to another episode of Agentic AI, the future of intelligent systems. In this episode, the focus shifts to enterprise agentic AI, and more specifically, to what truly determines whether autonomy can operate safely and at scale inside an organization. Enterprise AI capability is advancing at extraordinary speed. Every new model release expands reasoning depth, increases context windows, improves tool invocation, and embeds coding agents directly into development environments. Systems can now detect vulnerabilities, refactor production code, orchestrate multi step tasks, and coordinate across tools with growing sophistication. The acceleration is visible, measurable, and impressive. But enterprise agentic AI is not defined by how fast models improve. It is defined by how well autonomy is engineered around those models. That difference is not semantic, it is structural. Most enterprises today remain in what can be described as an augmentation phase. AI drafts artifacts, generates code, summarizes documents, surfaces recommendations, performs static analysis, and flags potential risks. However, workflow control remains human led. Humans initiate execution, AI assists within a bounded session, humans validate outputs, humans commit changes, humans retain accountability. The execution graph of the enterprise remains unchanged. AI is embedded inside nodes, but it does not orchestrate across them. Productivity increases, but system topology does not change. Enterprise agentic AI represents something fundamentally different. It alters the control plane of the organization. Instead of assistive intelligence embedded inside workflows, it introduces bounded autonomous execution across systems. That shift requires business processes to be decomposed into autonomous units. It requires explicit policy constraints enforced at runtime. It requires defined execution scopes, escalation thresholds, identity propagation across services, deterministic rollback strategies, auditability across every action, and persistent state management across agent chains. This is not a feature enhancement, it is an architectural transition from assistive intelligence to engineered autonomy. At that point, the central question moves away from what can the model do and toward what does the system allow it to do. A simple production question reveals the limits of model centric thinking. When a new model version is deployed, can deterministic compatibility with prior prompt logic and output contracts be guaranteed? The answer is no. Model upgrades introduce behavioral drift, output variability, latency shifts, and subtle changes in tool invocation patterns. These shifts are natural in evolving intelligence systems. However, when orchestration logic is tightly coupled to model behavior, even minor drift can destabilize production workflows. Enterprises must therefore design version pinning strategies, regression testing pipelines, structured schema validation for model outputs, staged rollouts, fallback mechanisms, and observability across reasoning traces. None of this is resolved by improved benchmarks. This is not a model problem, it is a systems engineering problem. Industry attention often concentrates on model progression, larger context windows, higher coding accuracy, improved reasoning benchmarks, stronger multi tool orchestration. These improvements expand capability. They reduce friction in certain task classes and enable deeper reasoning chains. From a capability standpoint, this progress is meaningful. However, model performance is really the primary constraint in enterprise deployments. The real constraint emerges at the integration layer. Enterprise agentic AI must operate across distributed systems. each with its own identity boundaries, access controls, audit requirements, data classification rules, compliance constraints, and operational dependencies. Autonomy must respect IAM policies, propagate credentials correctly, enforce runtime limits, maintain traceability across every action, and operate within financial controls. Even the most capable model cannot guarantee correct identity propagation across services. It cannot independently enforce financial guardrails at runtime. It cannot prevent recursive cost amplification across autonomous loops. It cannot ensure deterministic escalation paths or provide audit compliant execution trails across distributed systems. As model intelligence increases, the action space expands. Without corresponding improvements in integration discipline, that expanded action space increases systemic risk. Enterprise agentic AI is therefore constrained less by reasoning limitations and more by architectural maturity. There is a persistent misconception that improved models reduce the need for engineering. In enterprise environments, the opposite is true. As autonomy increases, so does the surface area for misaligned permissions, data boundary violations, escalation failures, cost overruns, resource amplification, and compliance exposure. Engineering responsibility grows, not shrinks. Enterprise systems must integrate scope tie IAM credentials, inline policy engines, structured tool access control, failure isolation mechanisms, multi step reasoning observability, runtime budget enforcement, and even carbon and resource attribution at workflow granularity. These are system level concerns. They cannot be abstracted away by stronger reasoning. Once models reach a threshold of sufficient intelligence, marginal gains in reasoning produce diminishing returns relative to integration stability. At that stage, the bottleneck shifts from model sophistication to system maturity. In practical terms, agentic AI becomes predominantly engineering. Models enable capability. Engineering determines whether that capability can be versioned, governed, audited, monitored, and scaled responsibly. Consider identity alone. In a truly agentic enterprise system, an autonomous agent cannot operate under shared human credentials. It must possess its own scoped identity, equivalent to a service account, with explicitly bounded permissions, traceable actions, revocable access, and auditable decision paths. Designing agent identity architecture, permission scoping, and lifecycle management is not trivial. Most organizations have not yet operationalized this layer. Without agent identity, autonomy is insecure. Without scoped credentials, autonomy is unsafe. Without auditability, autonomy is non compliant. Model vendors supply one essential component intelligence. They do not design enterprise identity architectures, they do not embed governance into distributed execution graphs, they do not enforce financial controls within cost centers, they cannot externalize architectural responsibility. Strategic differentiation will not come from access to the most capable model. Model access is increasingly commoditized. Differentiation will come from how autonomy is integrated, constrained, versioned, monitored, and observed. It will come from orchestration layers that manage agent lifecycles, identity aware execution frameworks, inline policy enforcement, structured audit trails, runtime budget controls, and carbon and resource accounting mechanisms embedded directly into execution flows. Enterprise agentic AI will not arrive through a single model release, a coding agent upgrade, or a new benchmark milestone. It will emerge through deliberate control plane engineering. It requires autonomy that is bounded, observable, enforceable, and resilient. Enterprise agentic AI is not a model play, it is engineered autonomy. And engineered autonomy cannot be outsourced. Until next time, keep building systems that are not only intelligent, but disciplined, controllable, and built to scale responsibly.